Well, good afternoon, viewers. Today we have a 2017 Ram 1500. I think it's a 17. 4x4. And it's got a charge indicator light on the dash. And I think it comes up with a message service charging system. I also noticed when I went to drive it in, let's zoom out a bit. So when I'm turning the steering, it's tight and then it gets loose. Tight, loose, tight, loose. So I think one of the U-joints in the intermediate steering shaft is rusty and seized, but that's a secondary issue. Now the history on this vehicle is that it was overcharging apparently, and the alternator was replaced, and the ECM has been replaced with one from Flagship 1. And it's no longer overcharging according to the tech that I talked to, but it still has this charge indicator light and it's setting a code. I can't remember what it is, but we're going to throw the scan tool on it and see what codes it has to offer. So it's detected the vehicle as a 2017 Ram 1500. I don't know the history on this vehicle because it's from a used car lot. It was bought at auction or something. I see it has a new battery, new ECM, and a new alternator on it. So let's do a network code scan. I believe I can do this running. Generator voltage sense circuit, P063A. It would be nice to know if that code has been there since the beginning. He said originally it was overcharging, and now it seems to be charging normally, according to him. A lot of these newer computer-controlled charging systems will still charge with a default value. He drove it 35 kilometers to get here, so I'm sure it is charging. Humidity sensor. I noticed the AC is not working. The compressor is running, but there's no cold air out of it. Lost communication with intelligent battery sensor. Stored, that's a history code. Ambient light control, door ambient light control. ECU reset or recovery. Recirculation door control, performance incorrect operation. Touch screen locked. KIN IGNM communication, radio frequency hub. Okay, so the only real concerning code is this P063A. Let's go into the engine control computer and have a look at data. And I'm not sure if it'll be in the engine data list or accessory data list, but it should show me system voltage. Well, the generator duty cycle is at 44%. There are just too many data parameters now, Snap-on. We need a keyword search. So it's sitting at 14.15 volts. The second last data parameter I'm looking at. So I'm going to pull up some cases on P063A and see how that code sets, see if there's any TSBs on it. I'm going to do a network code clear. That has to be done on Chrysler products without it running key on engine off. Battery voltage is at 12.6 right now, so I haven't put a battery charger on it yet, but I may. These are usually pretty quick. Okay, so let's copy the VIN. And let's load it up in Identifix and see if there's any keyword search. P063A. No cases on it. Let's look at DTC troubleshooting. Electronic voltage regulator maintains the system voltage at desired level by turning the pulse width modulated alternator field control circuit A on and off. When the alternator field is turned on, the system voltage increases. When the field is turned off, the system voltage drops. The rate at which this happens is dependent upon the existing electrical loads, ambient underhood temperature, engine speed, constant system voltage. B, C, D can be maintained only when the alternator field is switched on and off at a duty cycle that very accurately emulates the existing electrical loads. Okay. The alternator sense circuit voltage is less than the battery field circuit voltage. So the E wire is the sense wire, shows a fuse in it. That's interesting. I wonder if we can see the status of the alternator sense voltage on the scan tool. I'm going to put a battery charger on this so I can have the key on without the battery going flat. So upon further reading here, it says during normal operation, the voltage reading at the alternator output stud will be very close to the target charging voltage viewed on the scan tool. This is the system voltage and is sensed by the powertrain control module through the fuse B+ circuit. With the alternator connector plugged in, the voltage reading on the alternator sense circuit will be approximately 3.5 volts less than the voltage at the alternator output stud due to the resistor inside the alternator. Isn't that special? It's good to know. This is the alternator sense E input to the PCM. These two voltages sense inputs are used and compared during different diagnostic performed on the electronic voltage regulator system by the PCM. Well, I'm going to look through the data list and see if I can see any data parameters related to this. Then we're going to do a visual inspection. So in the accessory data list in the ECM, I see voltage sense, and right now it's 13.6 because I have a clean battery charger on it. And the target charging voltage is 13.9. It's not running, just key on with the battery charger on it. I also saw something else interesting in here. The intake air temperature reading was -64. Intake air charge temperature -64, but that could be an erroneous data parameter because it's not setting any fault codes. Now, theoretically, if this voltage sense is coming from the alternator, if I unplug the alternator connector, that should go to 0. So I'm going to pull the engine cover off and have a look in there. So I unplugged the 2-wire connector at the alternator, and that voltage sense is obviously not coming from there because it didn't change. I'll show you where that is on the vehicle. So this is the 2-wire connector I took off the alternator. And according to the schematic, one of these wires is a voltage sensing circuit. So I'm going to read the actual factory troubleshooting chart for this code and see. Maybe I should look at the pins inside that alternator because that doesn't plug in very good. I had that once where the pin was bent over. So looking in the connector, it looks clean and the pins are straight. So I'm just checking pin grip on these terminals. Boy, this terminal is spread apart. There's no pin tension whatsoever. I'm going to try and reshape that terminal. Normally you pry this white plastic piece out. This looks like an ignition coil connector. There's no pin grip whatsoever on this pin. If I turn this over, it'll just fall right out. And the second one is very poor as well. Somebody's jammed something in those terminals. So we'll try and reshape those two pins. So I depinned the terminal. And this is the mating terminal here. So I'm trying to reshape this. You gotta get a smaller needle. I can push it through from the back. Wonder if I have any of these terminals. This one is really bad. So there's actually a little hole in the side of the terminal. So if you put a needle in there, you can pry the terminal back into shape. I needed coffee this morning. That's good grip now. So we're going to do that for the other terminal as well. Pick them out one at a time and you won't mix them up. Let's see, which way does this go? Goes in this way. And to release it, there's a plastic tab. You have to push away from the terminal and pull out on the wire at the same time. Just like that. There's a bit of grip there, but not very much. That's got good grip now. Alright, let's put this back together and see if we're lucky enough to have that be the only thing. I doubt it, but gotta start out with the basics. Where's that plastic piece? I'm going to put a little dielectric grease on the seal. I'm going to start it up and see if the battery warning light is still on. The door ajar, and the battery warning light is still on. Let's see if the code came back. Well, we have the intake air sensor because I got it disconnected, but the generator voltage sensing circuit P063A, of course it could have came on because I disconnected the alternator. So I'm going to clear the codes, and of course I have to do that key on, engine off. So I've got the key on, engine not running. And of course it's going to reset the intake air sensor code because I have it disconnected. But the other code has gone to history. Maybe it only sets that code while it's running, so let's start it up. for this code, and Riser wants to do resistance testing on that wire to qualify it between the alternator and the ECM. It says disconnect the alternator harness, connect adapter GPEC diagnostic. So they have a breakout harness for the ECM, because they say if you probe the ECM terminals, you'll compromise the terminals, which is very well possible because somebody's been probing these terminals. And they've spread the terminal apart like they were at the alternator, it'll keep generating the same fault code. Measure resistance of the alternator sense circuit between the alternator harness connector and the GPEC adapter. Repair A804 alternator sense circuit for open or high resistance. Oh brother. Well, let's have a look at the electrical diagram. So this theory of operation diagram shows a fuse symbol in the E circuit wire, and in the actual schematic it shows no fuse. Generator sense wire is pin 2, red, violet. It doesn't show anything, it just goes straight to connector 2. Oh, there's a couple of asterisks here depending on what end you control. So the pin 1, the brown-gray wire, should be duty cycled, and pin 2 should be a sense voltage, according to the theory of operation, about 3 volts lower than the system voltage. So let's measure it, backpinning it. So that's the generator control, and it's duty cycled. I'm using a graphing multimeter. If I use a lap scope, you'll be able to see it in more detail. So you can see us being duty cycled. But I'm curious about what the other wire shows. So that's the brown wire. So I'm going to backpin the other wire. So that's the voltage on the sensing wire. According to the description and operation, it's supposed to be about 3 volts less than battery voltage. And I've got 14.2 right now at the battery. Trying to make a connection here. I got 14.05. So let's see if we got that voltage at the ECM. So even with the key off, I have 12.75 volts on that wire. I wonder if it could be shorted to voltage. Theoretically, if that's sourced in the alternator, it should go away when I disconnect it. Let me disconnect the alternator. I don't know if my back pin fell out. Okay, I got 0 volts on that wire with it disconnected. So let's check pin grip at the ECM. I know it's been apart. So I'm assuming that the inboard connector closest to the engine is connector 2, but I could be wrong. According to this, it's pin 35, and if I look at this connector, I took the plastic insert out. There's no pins in pin 32 or 35. So it must be this connector. But I assumed it was this one because somebody's been somebody's retaped it. But we'll look at the other connector. I'm going to try and see if it says in the service literature the color of the connector. So assuming that connector 2 is the left one here, or the one closest to the right fender, there are pins in locations 32 and 35, unlike this connector. On the schematics it shows both connectors as being black, yet one is gray and one is tan or beige, or it could be referred to as natural. I don't have voltage on that pin 35. I'm going to double check it. So I think that I'm on pin 35. It's so hard to see. It's not numbered. I got a voltage of 12.5 volts coming out of the alternator on that sense wire, but if that's the correct sense terminal, I've got 0 on it. I'm going to see if I can double check to make sure I'm on the right pin, the right connector. Man, they could certainly make these information systems more convenient. So I found this picture. Connector 1 is closest to the engine, and it's connector 2 that we should be on, which is the one closest to the right fender. And if that's the right pin, then that wire is open somewhere between the alternator and the PCM. So I'm going to see if I've got it on the right pin. So that is the correct terminal. I've located the wire by taking the back of the connector off, and I've got a temporary piercing probe on there, Phil's probe, and got no voltage on that wire. So what we're going to do is we're going to temporarily run a jumper wire from this probe to the back of the alternator, reconnect everything, and see if that fixes it. That wire is compromised somewhere in the harness between here and the alternator. So I got a jumper wire running from the back of the alternator sensing circuit, back pinning it to the wire going into pin 35 at the ECM on connector 2, and I've got the voltmeter monitoring, and it's 12.7 volts. So I'm going to start the vehicle now and see if it sets that fault code. So I'm clearing the fault codes out of the ECM. We'll only have the intake air temp sensor code. And last time we saw it materialize in this screen when I started the vehicle. So I'm going to start it up. And we get to listen to my compressor run now. Let's move that trouble light so it doesn't fall in the rad fan. Well, no warning lights on the dash. And I see it hasn't populated the code yet. Just got the air temp sensor code. I'm going to disconnect my jumper wire. Disconnecting it right now. Okay, so that wire is compromised somewhere between the alternator and pin 35 of connector 2. It's an open circuit. So according to the schematic, there are no connectors in between the connector at the generator or alternator and the PCM connector 2 pin 35. The wiring harness runs down the driver's side of the engine under the power steering reservoir, around the back of the alternator. Power steering reservoir? No, that's engine oil. Phil, I was going to say this thing should have electric power steering. And it runs around the back of the intake manifold I'm going to do a visual for a few minutes, and if I can't find anything obvious, we're just going to run a new wire and bypass that circuit. I'd like to find the root cause of the problem, but that might mean pulling the entire harness apart, and that's not cost effective. So it's back together and running. I ran a new wire, put it in loom, ran around the back of the intake manifold, taped up the harness. I opened the harness at both ends, tried to pull on that specific wire, but no luck. So I just ran a new wire. We still have the intake air temp sensor circuit code because I have it unplugged. I'm going to plug it in now, put the air induction system back together. So there's the air induction back on and all the codes cleared. Let's see what it's running at voltage wise. It's under engine, I believe. Target charging voltage is 14 volts. I think it's on this side at the very bottom of the list, where it calls it sensed voltage. Generator duty cycle is 45%. .1. So we'll just go back and rescan it for codes, but I'm sure it's good now. So that's it for this one. Customer has to deal with the potential oil change, this seized universal joint in the steering intermediate shaft, and the AC not working. Maybe we'll have a look at the AC data parameters. So I got the AC on. The AC clutch is on. It says true AC high side pressures is 100 psi. That's a little bit low considering it's 27 Celsius in the shop here right now. So I'm sure it's low on refrigerant because it's not blowing any of at all cold air out of the vents. But he can deal with that. It's the 1234YF system, and I'm not set up to deal with that.